You hatch from a small white egg somewhere inside a nest in the leaf litter of a Florida scrub forest. The nest is modest, a shallow series of chambers under a log or a rock containing a few dozen workers and one queen. You are not the queen. You are a worker, and you will spend your life performing the tasks that keep this small colony alive. But before you do any of that, you need to understand what you are carrying in your head. Your mandibles are not normal mandibles. A normal ant opens its mandibles, grabs something, closes them. Your mandibles open to a 180-degree spread, fully perpendicular to your body, locked open by a trigger mechanism. The spring tension in those open mandibles stores enough energy that when the trigger fires, they snap shut at a speed that has been measured at up to 64 meters per second at the tip. This is one of the fastest movements of any biological structure ever recorded. A blink of a human eye takes approximately 150 milliseconds. Your mandibles close in less than 1 millisecond. This is Odontomachus brunus, the Florida trapjaw ant. You are small, about 12 millimeters long, which is large for an ant but not impressive by any other standard. Your colony is small. Your range is limited. The Florida scrub is a fire-dependent ecosystem maintained by periodic burning, and your colony is tied to a specific patch of habitat that is being steadily reduced by development and fire suppression. You live in a narrow range of conditions, and the conditions are narrowing. But you have the jaw. You use it for prey capture. Your primary prey items are small arthropods, other insects, spiders, small isopods that move through the leaf litter of your territory. You hunt by walking slowly with your mandibles cocked open, the trigger mechanism primed, and when a prey item contacts the trigger hairs on the inner surface of your mandibles, the snap happens before any neural processing has time to occur. You did not decide to snap. The mechanical system fired. Your prey is compressed between the mandible tips and your body in less than 1 millisecond. Then there is the escape mechanism. When a predator, a spider, a larger ant, a small vertebrate, attacks you, you can use your mandibles against the ground. You position yourself and snap your mandibles against a hard surface. The recoil launches your body into the air. The jump has been measured at up to 8 centimeters in height and up to 39 centimeters in horizontal distance. You have no wings. You have just used your jaw as a catapult. This works. It removes you from the immediate vicinity of the threat. It also has no precision. You do not land where you intend to land because the snap sends you in whatever direction the geometry of the snap dictated. You might land next to the threat. You might land somewhere worse. The jump is an emergency measure, not a navigation system. Your colony is also capable of collective escape. When the nest is threatened, multiple workers snap their mandibles simultaneously against the ground or against the intruder. The force of multiple snaps sends the intruder and several workers in random directions simultaneously. Studies have shown that this behavior effectively dislodges attackers that would otherwise overwhelm the colony. The cost is that the defending workers land randomly and have to find their way back to the nest. You are a forager. You leave the nest alone or in small numbers. Trapjaw ants do not form the long raiding columns that army ants or fire ants form. You move through the leaf litter in a searching pattern, mandibles cocked, waiting for contact. The Florida scrub is relatively dry and open compared to tropical forests, and the leaf litter is thinner than in moister habitats. Prey is not abundant. You may cover significant ground before finding anything. You find the small cricket nymph, roughly your own size. It is foraging in the leaf litter and has not detected you. You approach. Your mandibles are already open. When the trigger hairs make contact with the cricket's leg, the snap fires. The cricket is struck and immobilized. You carry it back to the nest. The nest receives it. The queen eats. The larvae are fed. The colony persists. Skip forward. It is summer. The Florida scrub in July is hot in a way that concentrates activity in the early morning and late evening. The midday heat makes foraging energetically costly and dangerous. You forage at dawn. The leaf litter is damp with dew, and the small invertebrates that share your microhabitat are active. You encounter another ant, It is not from your colony. It is a fire ant, Solenopsis invicta, a worker from the invasive population that has established itself across the southeastern United States. Fire ants are aggressive, numerous, and toxic. A single fire ant worker can sting repeatedly. A fire ant colony can contain hundreds of thousands of workers compared to your colony's few dozen. You snap your mandibles at the fire ant. The snap strikes it. The fire ant recovers. Another fire ant worker arrives, then another. You are producing alarm pheromones, which may recruit nestmates, but you are far from the nest and the recruitment takes time. The fire ants sting you. You die 30 centimeters from the nest entrance. Other workers from your colony will encounter your chemical signals and potentially avoid this area. The fire ant workers move on. They are not foraging here specifically. They are expanding territory, testing boundaries, doing what invasive fire ant colonies do across Florida. Your colony faces a problem that your mandibles cannot solve. Odontomachus is well equipped for the prey and predators of the native Florida scrub ecosystem, the same system that shaped its evolution over millions of years. Solenopsis invicta arrived in the United States in the 1930s, probably through the port of Mobile, Alabama. It has since spread across the southeastern United States and beyond, displacing native ant species and disrupting the ecological relationships those ants were part of. Your colony is one of the native communities absorbing that pressure. The trapjaw has been recorded coexisting with fire ants in some Florida locations. The mandible defense works against individual attackers. It does not work against a colony that outnumbers yours by 4 orders of magnitude. Skip forward again. It is October, the scrub has dried, and the forest management team has determined that this section requires a prescribed burn to maintain the ecosystem's fire-dependent character. The burn happens on a Monday morning. The scrub moves through the scrub. Your nest is under a log that burns. Most of the colony dies in the burn. This is normal. Prescribed burns are necessary for the Florida scrub ecosystem to function. The native plants and animals, including Odontomachus, evolved alongside periodic fire, and many are adapted to it. Some workers and broods survive by going deeper into the soil. The queen survives. The colony will rebuild. But rebuilding takes months, and the habitat after a burn is initially simplified: less leaf litter, less prey, fewer resources. The colony that emerges from the rebuild will be smaller than the colony that went into the burn. It will take the better part of a year to return to pre-burn productivity. You do not survive the burn. You were foraging at the edge of the burn perimeter when it reached you. You were carrying a beetle larva back to the nest. The beetle larva and you both became part of the burn. The queen in the rebuilt chamber below the burn surface begins laying eggs. New workers will hatch in 3 to 4 weeks. New foragers will begin working the recovering scrub within the month. The mandibles they carry will be just as fast as yours were, 180 degrees, 64 meters per second, less than 1 millisecond. The Florida scrub will bloom after the burn. The scrub jays will work the open sandy patches. The gopher tortoises will emerge from their burrows. The recovery will happen. It always does. And in the leaf litter, a small ant will walk with its jaws open, trigger primed and waiting.